these are the notes for section 3.2, function notation. And the idea here today is to get into more of the details of what it is to be a function, what makes something a function, some visual stuff. So how would you know from a graph? Does a graph represent a function? And then doing function operations, which are several things. The first thing we got to hit is notation. So how you write it and how you work with function notation. It's pretty easy up front. As we get towards the end of the notes, you guys might start to feel like it's getting a little bit thicker. But things we want to do is tell the difference between a function and a relation. Talk about how the words and what the domain and range and notation means. Do a little bit of operational stuff and some visual stuff. And that's kind of a summary of what you see there. So for starters, let's go back to domain and range for a second. Same problem we talked about yesterday in the notes, that idea of the three runners that run the race in different ways but actually start and finish the same in 10 seconds. So your domain means 0 to 10 seconds. So when you're doing domain, think x, think x-axis. So we'd say 0 to 10. You could write as an inequality, which I'm not too worried about you guys doing. We could say that x sits between 0 and 10. Then we do something like this. So 0 to 10 in words, or x domain sits between 0 and 10 are both correct. Range is y value. Range was, in this case, distance, how far we ran. But it was a 100-meter race, so we could say range was 0 to 100. So 0 to 100. But range are y values, so we could say that our y sits between 0 and 100. So when you're asked to do domain and range, I'm okay with the word sort of model from where to where. If you like the inequality model, that's fine too. But just to recap from yesterday, what do we call domain and what do we call range? Domain is x, range is y. The next thing to do is just talk about how you describe a function, like what is it? And we really start by talking about a relation. So a relationship here, because we're talking about a mathematical relationship, is a relationship between x and y. How we know it's a function or not is a unique relationship, which is only one x corresponds to one y. A good way to start with is a set of ordered pairs. And as you guys scan through that set of ordered pairs, if you see any repeated x's, and that's the key, a repeated x means that's not a function. Because then if you have one x going to multiple y's, that's not a one x to one y situation. The place where that's happening is right here. And also right here. So I think I'm going to jump down to the mapping diagram for a second, which kind of helps you guys see this. You have 0 going to -2 and 0 going to +2. And you have 3 going to -1 and 3 going to +1. That's not 1x going to 1y, that's 1x going to 2y's. That would be considered not a function. So right up front, the way you determine is it a function or not is you say does one x value correspond to one y value. So a function is really a special type of relation where you got that one-to-one thing going on. So if you were asked the question, is this a function, we would just say no. If I say y, you'd say, well, the x's are repeated. So that's telling me that there are multiple y values assigned to the same x value. If you do domain and range is a list. So list out your domain values, 0, 3, and 4. I know 0 pops up twice, 3 pops up twice, but you don't have to list them twice. That's still all part of the domain. Range, list out your y values, -2, 2, -1, 1, and 0. So again, kind of emphasize a couple things, like domain and range, we get that, that's the x and y idea. What makes a relation a function? 1x to 1y. And then the things we see in 1, 2, and 3 are just other versions of the same thing. So a set of coordinates that is written as an actual set of coordinates. A mapping diagram, it just maps the coordinates one to the other, x to y. So if we're talking about domain and range, here's x, here's y, or we could say this is our domain, this is our range. A table of values, which you guys have dealt with that before for graphing, so here's a table, lays it out the same way. Again, when I see things going on like this and like this, I go not a function. One x corresponding to the same x corresponding to two different y values. So again, what makes it a no is repeated x values. Now, on the other hand, it's okay to have repeated y values because that'd still be 1x going to 1y. So if the y's repeat, not a big deal. 1x corresponds to one y value. Okay, that's how we define a function. So if that's the case, let's put it into a context of some real world scenarios, because if you guys ever hear, I don't know if you're ever listening like keyed in, but when I hear the word function out there in the regular world, let's say, I think of it sort of mathematically, like this is a function of this, okay? So the spread of the coronavirus is a function of, is it a function of time? Is it a function of, where it originated? Is it a function of travel overseas? Is it a function of, so what's the relationship? Is it a one-to-one concept? Some things are one-to-one, some things are not. Now that relationship may not be a function, right? Is it a one-to-one idea? But these things are listed here. Let's talk about them as, are they a function or not? So in order to say yes or no, you've got to ask yourself, is it one-to-one? So X city has Y zip code. If you think about it, just in Eden Prairie alone, we have more than one zip code. So if you're in a city that has more than one zip code, that'd be one city corresponding to multiple zip codes, or one X going to multiple Ys, not a function. Now, it could be in a small town, one zip code, one city, one zip code. So it kind of depends on this one. I'd say not a function in large cities because we have multiple zip codes, but in a small city you can say sure, one-to-one, one X, one Y. X state has Y capital. Now if you think about this, does any state in the US have multiple capitals? No. One state, one capital, that's a function, one-to-one, one X to one Y. X is friends with Y. Now some of these are kind of sort of, yes or no, they might be. You could be like you've got the one person that's your best friend, you have one friend, and that's it. Fine, it's one-to-one. If we assume you have multiple friends, then we might say, well, it's probably not one-to-one. Assuming that most people maybe have more than one person that they hang out with, but we wouldn't have to be. So there could be one-to-one. You got just one person that's your best friend. That's it. X is Y feet tall. So we're talking about X being like a person. Now this has also got a little bit of a twist to it. We'd have to think about this as like right now, as we speak. Then it's one-to-one. If you say like a span of my lifetime where I'm growing, well then of course not, right? At your age 1 to age 10 to age 20. But if we say in this moment, as we talk about it, it's one-to-one. I have only one height right now as I talk to you guys. So again, trying to kind of get the context of something being a function of something else. Well, is there a one-to-one connection? And if you really listen, kind of pay attention, you're watching the news, you're reading the news, you listen to other people talk, the word something is a function of something else gets thrown out there quite a bit. And then you might want to think about, if you hear it, did the person use it correctly? Now, graphically, functions are really easy to figure out. So one-to-one, one X goes to one Y. Well, we have a test for this that works really nice called the vertical line test. And it's pretty simple. What you do is you take a vertical line and you pass it to your graph. If at any spot along the way it's only hitting the graph once, that's one X corresponds to one Y. So for example, let's say I stop at 2. Right here, X is equal to 2. Now my graph, I'm hitting that one spot. That vertical line is not touching the graph anywhere else. One X corresponds to one Y. So this one's a function. Now take your vertical line over here and pass this graph, no. Because now let's say I stop at 4, for example. I'm hitting the graph twice, which means one X is attaching itself to two Y's. That's not one X to one Y. That's not a function. And a circle would of course fail the vertical line test too, so no, because you're failing like all over the place. Fail, 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 right? Not a function. So visual test, based on a set of coordinates, based on you just reading some expression, a sentence, what makes it a function, however you look at it, whatever set of information, one X corresponds to one Y.